All right, here we go with our last main topic of our lesson here. So we want to be able to write the equation of the LSRL, the least squares regression line, and we'll be talking about what that means here shortly. I think in the next lesson in a couple days. So we want to know what that equation of the least squares regression line means, how to calculate that if you're given different various statistics, okay? We've got to have many ways that we can reach that goal. So we know one of the main ways is we get all the data points. So if you get all the actual data points, you go line those up into your calculator, L1, L2, and you use that calculator's linear regression function, statcalc okay? And then we compute the LSRL, the least squares regression line. Okay, but sometimes you do not have all of the data points. You have instead been given these summary statistics. You have been given the correlation coefficient, the R, so how the data was correlated, okay? You also knew how varied the data were for the x's, how varied the x's are, so that you have the standard deviation of the x's, and you know how varied the y value is, okay? So we also are given this third item, because what happens is we're going to find, okay, what things do we need to do a line, to do our linear equation? Slope and y-intercept, okay? So do you recall the components to slope? You remember how you can do in slope? You heard of her rise over run, okay? Rise over run, change in the y's over changes in the x's. Well, we're going to find that we're going to do the same thing, but we have that variability in the y's over the variability in the x's times how well they are correlated together. So we're going to end up finding that our slope, instead of rise over run, change in y's over change in x's, difference in y's over difference in x's, it's going to be that variability in the y's over that variability in the x's times how well that data is correlated together. So see, we can take these three things right here and get that slope. Okay, so that's the first big thing. Now, okay, so let's now think back to Algebra 1. If we had a slope, what else would we need to be able to get an equation of the line? Well, if we had a slope and then we needed to get the equation of the line, we needed a point on the line. Have you ever heard of the point-slope equation? Okay, we need a point on the line. Well, guess what? In a lot of these cases, we will be given this thing called the mean point. And that mean point is a point on the line. That is always, I talked about that in the previous video, that value point with the mean of the x's and the mean of the y's is always a point on the line. The mean of the x's and the mean of the y's is always a point on the line. So I got a song for that. So here we go. Of course, we just talked about this, that the slope of your least squares regression line is that variability of the y's over the variability of the x's times how well they are correlated. And then our point on the line is our mean point. So x bar is the mean of x and y bar is the mean of y. And the mean point is always on the line, on the line. Okay, so real quick, let's listen to that. It's kind of a short little song. Here we go. I like the acoustic version of it. X bar is the mean of x. Y bar is the mean of y. And the mean point is always on the line, on the line. X bar is the mean of x. Y bar is the mean of y. And the mean point is always on the line, on the line. Okay, so there we go on that one. All right, so remember that mean point is always on the line. Okay, so let's go through our stuff. Here we go. Let's practice it. Let's do it and get her done. So here we have Becky's parents kept record of her age since she was born. So we have all the X's, okay? And so we have the X bar. I had to write X bar because my key program doesn't give me the ability to write the X with a little bar over it. So I just wrote X bar. But if you're doing this on your notes, you're just going to do like this, your X bar with a bar over it, okay? But I couldn't type that. X bar has a mean of months, okay? And then her Y bar, her height, is the response to that. So we've got our Y bar. Okay, so there's our mean point, 44.82. And then over here, look, we got the standard deviation of the age. So that's the standard deviation of the X's, standard deviation of the Y. So that's the S of Y's. And then we know the correlation. Okay, because it tells us right here, correlation. So let's do this. First thing, step 1, find your slope. Variability of the Y's over the variability of the X's times the R. Okay, so make sure you get that in the right order. The Y's over the X's, okay, so here it is. The 4.1 over the 8.5 times that correlation, that's 0.41. So that's our slope, 0.41. Now, you are welcome from this point on, you've got options of how to put that point and use the point slope formula, which is that x minus x1 equals m times y minus y1. Or maybe it's the opposite. Y2 minus y1 equals m times x2 minus x1. Okay, I think that's it. All right, but I don't do that. I usually just do this. Watch. I got my y bar. Okay, I just go like this. Y equals mx plus b. I go y bar equals m times x bar plus that y-intercept. Okay? So guess what? I got all these things. Look here what I have. I have got y bar is 82. I've got slope is 0.41. I have got x bar is 44. So I'm going to plug in those 3 things and solve for the y-intercept. So do that. So then I come over here. There it is. 82 equals slope times x bar. And I solve for y-intercept. Y-intercept is 63.96. So that then gives me this equation right here. Predicted height is 0.41 times her age plus 63.96. That's it. Okay, and that's the last thing of this lesson. Here's one more for you to practice if you want to. So I'm going to let you stop the video and do a little bit of practice on this. I will cover up these answers real quick. Let you take a look here at this. Stop the video. Get your slope. Put in your y equals mx plus b and solve for the y-intercept. Here's the answers. I'll reveal it and see if you got it right. There we go. Okay, that's the end of our lessons. So now you can do your work for this section.